In this lecture, I'm going to be giving a broad overview of supervised machine learning. And so this is the figure from the Grimmer 2013 article that you were to read probably six lectures ago right now that just introduces text analysis methods for political science. And we've gone through acquiring documents for social media data, working with the R tweet package in R, how to pre-process these data. We've done a bit of ideological scaling with the model from Pablo Barbera and my own model for looking at news media scaling. We've done LDA models. And now what we're going to do is go to this side of the tree right here. And because we've looked at dictionary methods as well, but we're going to be looking at supervised learning methods in general. And so I've talked about this a little bit in previous lectures, but there are two types of methods very generally in machine learning and as are used in the social sciences. Generally, those are unsupervised approaches and supervised approaches. So unsupervised approaches are when we learn from the structure of the data themselves so that we don't have labels on the data. So for example, if we were looking at political ideology, we don't know the ideology of any single user, any single social media user in our data set. Or if we're doing topic models, we don't know any of the topics. So we simply want to, we have a set of data and we want the computer to tell us what are the topics in these data, or what is the ideology of all of these users who we don't know the ideology for from the beginning. The variety of cluster analysis techniques, there are quite a number of unsupervised learning techniques. So we've gone through LDA, we've gone through IRT. We haven't touched on cluster analysis, but really LDA is a sort of cluster analysis technique for getting at topics. So today what we're going to be talking about are supervised learning approaches. And they differ from unsupervised learning approaches in a key respect, and that is that there are, in supervised learning approaches, the data that we have some labels for the data. Typically not for all of the data, but for usually a small subset of the data. And what we're going to try to do is learn the relationship between the variables that we might have in those data. And so in the machine learning literature, there is some different terminology, but often you'll see the word features right here. But anytime you see the word features, just think variables. It's essentially the exact same thing. It really is the exact same thing. And then for the outcome in these models, you can think of this in kind of regression terms. There are regression-based supervised learning techniques, but we have these features, which are the variables that would appear on the right-hand side of a regression equation, and then we have some labeled values for our left-hand side, or for our y, right? So we have a bunch of x's, which are our features, and a y, which is our outcome value. And I'll give you an example of what this means in just one second. And so our goal is then, typically, although not always, our goal is to predict the labels on the cases that we have labels for, and then use that model to make out-of-sample predictions for the data that we don't have labels for. And this is important for a number of reasons. And especially because we want to, if we want to scale up a label, say for we have 10 million tweets, and we have labels for the topics, or for maybe 10,000 of them, we want to fit a model to those 10,000 tweets, and then use that model to predict what the labels are for the other 1 million or 10 million tweets. So there are benefits and there are drawbacks to supervised learning. The benefits are that researchers get to decide what the concept is that is being measured, often with unsupervised techniques, especially with ideology. If you're trying to scale ideology and you use data that actually don't tap into ideology, then you're not necessarily measuring ideology. And in some cases, it's sort of unclear what is being measured with unsupervised techniques. So in the LDA example we have a number of topics that the computer will find, and we'll look at, say the top 10 or 15 most frequent terms in a given topic, and it will be unclear what's actually being measured, right? There will be some sort of uncertainty about what a specific topic is because some of the words that are highly associated with that topic don't seem to mesh well with some other words that are predicting that topic. So the benefits are really that researchers get to specifically decide what is being measured, and the resulting measure is easily interpretable. The drawbacks, however, are that because researchers get to decide what is being measured, you actually have to measure it, and that essentially often means manual annotation. So if you had social media data and you wanted to measure incivility, so whether a specific tweet is rude or impolite or is attacking a minority group, uh, and you have 10,000 tweets that you want to label, you have to take the time and potentially use money to go through every single tweet and create labels for those tweets so that you can turn your data from an unlabeled data set into a labeled data set, which you can use in a supervised learning setting. So this is just an example of looking at dictionary-based approaches versus supervised learning approaches to sentiment analysis, because we talked about sentiment analysis in the last lecture. So dictionary approaches are great in a few respects, and they have some pretty big drawbacks in other respects. So dictionary approaches are very cheap to apply. So as we saw in the last lecture, once you have a dictionary, applying it to new data only takes a few seconds. It's actually really quite easy to put together a dictionary or to use a dictionary. Creating a dictionary is time consuming, of course. These dictionaries are applicable across many corpora, many sets of documents, not specific to a certain corpus. And the drawback, though, is that a dictionary's its generality means that its performance is not going to be great across that many sets of documents. It's a very general, sort of crude tool for tapping into sentiment in a given set of documents. Then, on the other hand, we have supervised learning approaches. These are what I've said here is expensive to apply in the sense that you need to manually, or typically, you need to manually annotate a number of documents. It takes quite a long time. It's very boring. It's very time consuming to go through all of these documents to say whether a given tweet is expressing a positive or a negative or a neutral sentiment, compared to a dictionary approach where you can just apply the dictionary right away. Uh, but one of the really, really nice things about supervised learning approaches and this kind of approach of manual annotation is that it's designed to be specific to a given corpus. So if you have a set of tweets from politicians in Denmark, you can read maybe 10,000 of those tweets and annotate them for their sentiment, whether it's positive, negative, or neutral. And you will know exactly what you're coding and why you are coding something positive or negative, because you yourself come up with the code book to make those determinations. And so the benefit there is that because it's specific to a corpus, I spelled it wrong here, but it's specific to a corpus, it means that its performance will typically be much, much better than a dictionary-based approach. And we saw that in one of the articles in the last lecture. So this is an article from 2015 where they also measure the performance of machine learning. What they mean by machine learning here is really supervised learning, though. Machine learning does not necessarily need to be supervised. But they have a machine learning supervised approach. It's actually not a sophisticated one that they're using. The approach that they're using is a method from 1999, which is in machine learning terms is a very long time ago. And so the performance here would actually be better if you applied recent methods. But what they do is they look at the performance of sentiment dictionaries, these right here. I talked about ANU before, and we read about Lab MT for MTurk as well. I think Lexicoder is actually based on the LIWC dictionary as well. But these are the performance in sentiment dictionary-based approaches versus a supervised machine learning classifier that is specific to data from the BBC. I think they have these are news stories from BBC. These are posts from Twitter, posts on Dig. I forget what the data are from YouTube, but these are across 5 different domains, and how well do these dictionaries apply in each of these domains? And what they're showing here is that the machine learning approach uh, almost always is better than the dictionary approaches. So maybe this right here, sentence strength, is actually decent for YouTube, or it's more or less equivalent. But just in general, the machine learning approach is going to be better than these dictionary-based approaches. And then this is the table that I talked about in the last lecture, where we have these dictionaries, these 4 dictionaries right here, and how well they perform when looking at ground level truth for life satisfaction, happiness, worry, sadness. And so, where the LIWC dictionary says that a county in the United States should have a positive sentiment, it's actually negatively correlated with life satisfaction. So this is exact opposite of what we should expect. And so these word level, these basically dictionary based approaches, do very, very poorly. But on this side, we have these data-driven approaches. This is essentially a supervised learning approach, learning from the data about what a given sentence, whether it's positive or negative. So learning from the data to develop a classifier to determine whether something has positive or negative affect, and these perform a lot better. So where the machine learning classifier says that a county should have higher life satisfaction, we actually do see higher life satisfaction. Same with this one and this one, right? Um, so these data-driven approaches actually work quite well relative to dictionary approaches. And then lastly, this is an article. I think I put it on one of the reading lists maybe 6 or 7 lectures ago. But this is looking at supervised machine learning. That's what SML is. Supervised machine learning versus dictionary-based classifiers for. I think this is New York Times news stories, and supervised learning absolutely dominates these dictionary-based approaches. So there is a benefit to dictionary-based approaches, as I talked about in the last lecture in the Brie and Dufresne research note. Right, they were very easily. It was very easy for them to apply that dictionary to their data. Right, so I replicated their study from scratch in maybe 3 days. So it's quite easy to do that. But I had to apply a supervised learning approach and actually gone through and read every single tweet and or a subset of tweets to determine what is positive and negative sentiment in the yes and no campaign in Scotland. That would have taken me a couple weeks to do. Right, so I was able to do their whole analysis in 2 or 3 days from scratch. If I had used a supervised learning approach and actually followed through with their exact process, it would have taken me a number of weeks. So this is, I'm not going to read this. You can read it. It'll be on the lecture slides that will be included on the course website. But the basic idea here is what Gonzalez, Bailon, and Paltoglu from this figure right here. This is their article. I will include this on the course website as well if you want to take a look at this article. But what they're saying here is that lexicon-based approaches are, they're ready to use. So this is basically dictionary-based approaches. So dictionary-based approaches are very easy to use. They're very quick to implement, but they're not as good as supervised learning approaches. And so what they're really saying is that a lot of effort should be put. And basically, I'll just read this last sentence. But for this reason, and on the basis of our findings, we suggest that future research efforts concentrate on supervised approaches and on building training data sets that can be used to improve learning algorithms and increase their accuracy performance. So there is a place in the literature for using dictionary-based approaches, right? They're quick to use, they're easy to understand and implement, but supervised learning approaches are almost going to dominate them in all cases in terms of performance. So when we have a supervised learning problem, typically we have data that are unlabeled. So if you downloaded all of the tweets from, let's say, members of Congress or all Danish politicians, you have no labels on those data. And let's say you wanted to measure sentiment. You could apply a dictionary-based approach, but if you want to apply a supervised learning approach, you yourself need to find ways to label some of those tweets. You don't need to label them all. The goal really of supervised learning is to look at a small subset of the data, create a model for that small subset, and make predictions about all of the other tweets that that model hasn't seen, so that you can label, millions, tens of millions, hundreds of millions of tweets without having to go through and read every single one. So, how do we go about actually creating or finding labeled data? The easiest approach, if it's possible, it's rare that you can do this, is that you can use existing labels. So you might be able to think about ways of labeling your data that do not involve manual annotation, because manual annotation takes a lot of time and it can cost a lot of money. So one way to think about it is, let's say that you wanted to find all of the tweets on immigration. So hashtags on social media actually are a way for users themselves to signal the topic of a tweet. So not all tweets will include a hashtag related to immigration, but you could find the subset of tweets in your data that do have a topic or a hashtag that is related to immigration. Tag those as your labeled set. Find tweets on other topics that are clearly not about immigration. And then you will have a small subset of data which you can turn into a supervised learning problem. Other times, if you were examining ideology, for example, on Twitter profiles, people will actually say, I am a Republican, I am a Democrat, I'm an independent, I'm a libertarian. And so you could just use a regular expression to search for all of the users in your Twitter data that signal their partisanship. So most people will not say that whether they're Republican or Democrat or independent, but a lot of people self-label. So you can use these labels. So a subset of your data will have a Republican, I am a Republican, or I'm a Democrat, or I'm an independent, and you can use that as your label data set. Another way to think about it is so we've talked about nominate scores before. Nominate scores are just measures of the ideology of members of Congress based on their voting record. But you know that there are 535 politicians in the US Congress. They all have a nominate score. And let's say you wanted to measure the ideology of users on Twitter. Politicians, of course, are users. And so you have the ideology of those 535 members of Congress. And you might be able to create a model that predicts the ideology of users for these 535 and apply that model to the ordinary users on Twitter for whom you don't have a label. So you can put users on Twitter potentially in nominate space that way. You could also do it with party labels very similarly to nominate. So you know which politician is a Republican or a Democrat, for example. So this is these appear existing labels. It's relatively rare that you can actually find an existing label. And so often with these supervised learning approaches for social media data, you have to do the annotation yourself or pay others to do it for you. So often you can do it as a researcher. So if you wanted to label tweets as whether they are uncivil or civil, whether they're polite or impolite, you could pick out 5,000 tweets from your million tweet data set, and you could label them. You could go one by one, creating a code book, and I'll show you one just in 1 second. Creating a code book which determines the rules that you are going to go by when you classify a specific tweet as uncivil or civil. And then you just go tweet by tweet, labeling them as a 0 or a 1. A 0 if it's civil, and maybe a 1 if it is uncivil. So you can do that by yourself as a researcher, or if you're working with other students or with other researchers. You can also use undergraduates or graduate students. This is often done by professors when they have money from grants to manual to have others do this manual annotation. So you'll get a team of students to do these to do this manual annotation as well. And so you'll essentially train students on a given code book that you've developed. And then they will go through these, 5,000 or 10,000 tweets doing these labels. And there is a benefit to not necessarily for students like you, but there's a benefit to using multiple people to do this. So I'll talk about this in just one second, but there's going to be error. There's going to be measurement error, right? So my interpretation of what is an uncivil or civil tweet will differ from yours. And so we might have the same code book to go by, which tells us what determines what is civil or uncivil, but it's nevertheless our subjective opinion when we look at a given tweet, whether it is fitting the standards of a given code book. So it's often useful to have more than one person look at the exact same tweet to see if there's agreement on what is civil or uncivil in our example. And then the last option is very similar to expert annotation, but it is non-expert annotation. And this is crowdsourcing. Uh, and that is in the Benoit article from 2016. That's not the Benoit article is not looking at social media data, but the basic idea is it applies here, and that's to essentially hire people on these platforms like MTurk, Amazon Turk, or Figure Eight, or there are a number of these companies where you can hire just ordinary internet users and give them a code book, uh, train them on that code book, and then have them in the comfort of their home go through all of these tweets, labeling them as you see fit. And this Benoit article is just showing that these non-expert annotators actually do a really, really good job relative to experts. So you would think that experts actually do better, and I think they do on average. But ordinary users, or just ordinary people, ordinary citizens, actually do quite a good job. So this is just a graphic from the Benoit article showing how well the expert coding of the political platforms of parties are relative to that of the ordinary internet users, and it's actually the correlation is actually quite high, right? We have 0.96 correlation here and 0.92 correlation over here. So this is just an example of the use of wisdom of the crowd's approach to coding social media data. So one of the articles, the optional articles, you were to read one of two, but the article that looked at incivility, if you look in their appendix, which I had attached in the article on the course website, they actually provide what their codebook was. So they hired people on Crowdflower. So this right here. Figure Eight is the successor to Crowdflower, but they were doing this back in 2016 or probably before, probably in 2014 or 15. And this is the description of the coding scheme that they gave to these ordinary internet users. Because what they did is they asked ordinary users to classify, I think it's 32,000. It was a really, really large number of tweets for whether they are polite or impolite. And they had a number of other codes that they wanted to look at. And so these ordinary users on the internet just said, or saw in this job, you'll be presenting with tweets from the upcoming 2014 European elections. You will need to classify each tweet into the following categories. And so the researchers told these coders what is a polite tweet, what does it look like. It's actually a very brief description here. What is an impolite tweet? So these terrible words right here. And then they gave some example tweets. And then they asked them to go through a large number of tweets and encode them for whether that tweet was impolite or polite. And this process is actually quite involved. So coming up with these code books is an iterative process. So the first code book that you will come up with, if you wanted to code tweets, is not, or code anything really, it doesn't have to be tweets, any social media post, newspaper articles, anything. Your code book will not be that great. And often you're going to go through iterations because when you go to apply that code book, you'll find cases where the coding is ambiguous. And so you need to change how your code book is actually worded. And so they just describe here what they actually did. So they started with a training session of the coders, went through some exercises, um, asked them tested them to see if their coding skills were decent, looked at reliability. And when they came up with this code book, they would have gone through a lot of different iterations. So this is a quite an involved process. This is not a simple thing that you get done in a weekend. Coding like this actually takes quite a long time. So after the coding is done, uh, as I mentioned, when you code social media posts or you code any document, you want to check whether the coding is good. And so, what you will do is you'll ask multiple people, if you have multiple researchers or students whom you're working with for the coding, you're going to ask multiple people to code the exact same tweet. And your hope is that there's a pretty high level agreement. So if I were to code a specific tweet and you were to code the exact same tweet, hopefully we would agree that it is civil, or hopefully we would agree that is uncivil. Because if there is variation there, or a lot of variation there, if they're uncorrelated, that would be pretty bad, because that would mean that there's quite a lot of measurement error. And it would suggest that our code book is probably not the greatest. And so there are a number of, I'm not going to go into technically what these are, nor am I going to look at these in the lab. They're relatively easy to look up. If you can run a correlation in R, you're able to run a Spearman's row or a Kendall's tau b. So this is not very difficult to do. But you're going to have, for each tweet that you've coded, let's say you've coded 10,000 tweets, and you had 3 different coders code the exact same tweet. Then you can look at average agreement. So on average, how often do coders agree on the coding of each tweet? You can look at the correlation. If there are two coders for a tweet, you would hope that the correlation is very high. So if I say something is uncivil, you will also say it's uncivil. So the Pearson's correlation coefficient is just the regular correlation that you're all used to. There's a Spearman's row that you can use, which is a rank-based statistic. It's non-parametric. Anyway, there are a different number of ways of calculating a correlation. If you have ordered data rather than continuous data, you'll use a Kendall's tau b. And then there are intercoder reliability measures, which are specifically useful when there is more than one coder, or sorry, more than 2 coders per document. And so you often see these Cohen's kappas or these Krippendorf's alpha. So there are a lot of these kinds of measures. They're quite easy to learn if you actually do this on your own. They're not very difficult to apply. But all that to say, really, that you need to make sure that your coders are reliable. So hopefully they're in agreement on how to code each document that you're asking them to code. And so this is just another example. This is from the appendix from the Theocaris article. And they provide the percent agreement and how they coded in Germany and Greece and Spain and the UK. They looked at 4 different countries and incivility. They wanted to know, for those who didn't read this article, they are looking at whether tweets directed at politicians in Germany, Greece, Spain, and the UK are uncivil during the European parliamentary elections. And so they had a number of coders go through all of these tweets, and this is their agreement score. Like what percent of the codings were consistent between coders. They do a Krippendorf's alpha, and they show. I hadn't known actually what a Maxwell correlation was, but they have 3 different. They just provide 3 different measures for each of. They coded communication style, tone, and morality of these tweets, and they just. I'm just showing here that they provide the intercoder reliability statistics just right here. So in the next video, what I'm going to be doing is assuming that you have a coded data set, and how do we actually go about applying a supervised learning model to our labeled data so that we can get predictions for our unlabeled data.